We're so excited to be doing this digitally this year. The session is on what developers are doing with Postgres and MySQL on Azure. And our speakers today are Andrea Lamb and Samay Sharma. Andrea is a senior product manager on our MySQL database team and originally from Canada, which means she loves ice hockey. And Samay Sharma is a senior engineering manager on our Postgres database team and landed at Microsoft by way of Citus. And with that, I hand over the reins to Samay Sharma to start our talk. Thank you.
Thanks, Claire. Hey, everybody. I'm Samay, super excited to be here talking to you guys about a topic which I think a lot about and care a lot about, open source databases. So some of you attending this talk might be Postgres fans, and there might be others who swear by MySQL. Our goal at Azure is to provide you with the freedom to run whatever open source relational database you'd like and pick the one which is best suited for your application. So that's why we wanted to do this talk today, to share patterns on what other developers are doing using Postgres and MySQL on Azure so that you can look at those patterns, and if you have similar patterns, run those databases on Azure. So from an agenda perspective, we're going to first discuss why developers are running more and more open source databases on Azure. Then we'll describe a few patterns with what developers are doing with Postgres and what they are doing with MySQL. And then we'll cover how they are migrating their databases over to these services. So to start off, open source databases are continuously growing in popularity. I just wanted to project this chart to give an idea. If you look at it, all the top 4 databases are relational, which means relational databases are still the preferred method of storing your data. And you would also notice that MySQL is already among the most popular databases in the world, and Postgres is steadily rising to be among the top ones. And it's not just about popularity. These databases are being loved by developers, and that's kind of seen in Postgres being the database of the year for 2017 and 2018, and MySQL for 2019. In the relational database segment, MariaDB and Postgres are the fastest growing databases as well. So both these reasons, the popularity and the love which the developers are giving to these databases, make them extremely popular. The second movement, which is happening in parallel with this, is the movement to the cloud. 80% of companies invest in public clouds, and that number is growing steadily. So both of these reasons combined is why we see more and more deployment of open source databases on the cloud. And at Azure, we provide you the best place to run your open source relational databases. We run the community versions of these open source engines, which means that there is no lock-in, and you could actually run these anywhere you'd like. These community versions have been around for decades. They are stable, reliable, and battle tested, which makes them among the most powerful databases in the world. With Azure, we provide these to you as a fully managed database as a service, which means you get backups, high availability, reliability in the region of your choice. We also provide you the ability to scale these databases to any volumes you'd like with offerings such as Hyperscale Citus, which allow you to scale from hundreds of gigs to hundreds of terabytes. While providing these services and features to you, we make sure we provide the highest grade of security and compliance, which comes with all Azure services, which means your data is encrypted, your connectivity is secured, and you're alerted on any suspicious activity. Lastly, we also provide you features which allow you to tune these databases and improve performance. With features like Query Performance Insights and Azure Advisor, you get the visibility and the recommendations you need to improve your database performance. And while building your applications using these open source databases, we provide integration points with other Microsoft products such as Azure Active Directory, Data Factory, Power BI, so that you can run your application end-to-end on Azure. So now that we are seeing that with Azure, you could build your secure and high-performant application using a battle-tested open source relational database in the cloud in a very easy manner. Now, once we understand what developers are gaining from actually running these databases on Azure, let me walk you through a couple of patterns on what developers are doing with Postgres service. The first scenario I'd like to talk about is migrating Oracle databases to Postgres. It's a pattern we are seeing more and more of lately, and I wanted to share why developers are doing this and what is the process they are following. The first reason why people are doing this is they want to avoid purchasing and having to negotiate expensive licenses. They want to reduce vendor lock-in and be able to run on an open source alternative which provides them all the features they need. The second kind of main reason, which is kind of tied to the TCO, is if you're running these databases on-prem, you need to have an army of DBAs to keep your database up and running, to take care of security, patching, and upgrades, and so on and so forth. Whereas with a fully managed database as a service, all that is taken care of for you by us. What makes Postgres a very attractive target for this is that it's a very feature-rich database, which means it provides a variety of data types, indexes, geospatial features, among other things, which allow you to find an equivalent for any kind of feature you might be using on Oracle. One of the biggest worries or biggest questions which customers bring up while migrating their databases is how much is the migration effort going to be? And especially for Oracle, it's tied to stored procedures. Postgres' PLPG-SQL is very similar to PL/SQL, which allows for a faster and low-risk migration with very less manual intervention. And we provide a bunch of tools to help you through this migration journey. So we use a combination of open source tools such as Ora to PG and build tools within our Azure services such as Azure DMS to provide you minimal downtime migration. Now, I won't walk you through each piece on this, but I'd like to give you an idea of how we execute these migrations. So first, we look to discover and assess your current Oracle footprint and see like what the migration effort will be. For that, as I mentioned, we use a combination of open source tools and tools we built as a part of Microsoft. And then we actually migrate, we provide tools such as DMS, Azure DMS to migrate your data with a minimal downtime and then cut over your application to use the Azure database for Postgres service. The second scenario I'd like to talk about where we are seeing a lot of usage from Postgres is operational real-time analytics. I find this scenario to be super powerful because it's great that you can actually ingest data in real time and run complex analytics on it within the same database. And one thing which enables you to scale this across any data volume is a new offering we launched last year called Hyperscale Citus. Hyperscale Citus allows you to scale Postgres across multiple nodes, providing you with the scale and performance which you need for running such applications. And Hyperscale Citus is actually powered by an open source extension named Citus. I was part of the team which built this extension as a part of Citus data. And then we were acquired by Microsoft, and I'm super excited both about the acquisition and the availability of this product to all the Azure customers. Now let's discuss why Postgres is the right database of choice to build your real-time analytics applications. Firstly, it provides a variety of being able to do real-time ingestion with support for all kinds of transactional operations and complex SQL queries from any kinds of SQL constructs you want to run to analyze these databases. The second thing which it provides relevant to real-time analytics is a variety of data types, operators, functions, and extensions. With data types such as like time series data types, indexes you can create specifically on these kinds of like tables, and extensions such as pgpartment to manage partitioning, you are able to run these real-time analytics workloads in a very straightforward manner. You can also approximate your complex analytics queries by using extensions such as HLL and TopN. Now, in many real-time analytics scenarios, you do want to do some pre-aggregations and creation of summary tables. Postgres provides features which allow you to do this natively. And then because of the connectivity it provides with the rest of the data pipeline, you could actually analyze the data stored in Postgres with tools such as Power BI. With Hyperscale Citus, you do not need to worry about the scale component of this because you can actually scale this to whatever data volumes you'd like, including high ingestion rates and complex analytics over very large data sets. I'd like to conclude the discussion on this use case by walking you through a quick architectural diagram of how customers deploy real-time analytics architectures on Azure. You can follow along with the blue box for the pieces, components I'm going to be describing. So let's say you have an IoT application where you're pulling in data from devices. You can actually ingest it into Azure Event Hubs and then use that to then ingest the data into your Hyperscale Citus cluster. You can store your raw events in a set of tables and then schedule processes and jobs within the database to create your aggregations and summary tables. You could then move this data if you would like to do some background analytics or some offline machine learning to Azure Databricks. You can host your application on app services or Azure Kubernetes service and then have it connect to your database to run your queries on it. Your users can then look at their browsers and browse your application, which will actually hit your database live. So with that, I want to conclude the discussion on Postgres patterns, which we are seeing. And I'd like to invite Andrea to talk about the patterns we are seeing with MySQL.
Thanks, Samay. So now that you've learned about all the great things that you can do with Azure Database for Postgres, I wanted to talk to you about some of the cool things that you can do with the MySQL service. I wanted to talk to you about how you can use Azure Database for MySQL in some really interesting workloads. Now, for those of you who aren't already familiar with MySQL, it's a very popular open source relational database engine, and we often see it being used with PHP and Java application stacks. And this is often tied to web apps as well as package applications used for content management, e-commerce, and CRMs. And since many of us are staying at home right now, I'm sure everyone is using some form of online retailer, whether it's to buy groceries, everyday home items, or activities to keep you and your family busy during these times. Did you know that many stores are actually using Magento to host their websites? Magento is an open source e-commerce solution developed in PHP, and it works great with MySQL to store its data. In Azure, we offer various app hosting methods, including Azure Virtual Machines, Azure App Service, and the Azure Kubernetes Service, or AKS. AKS is what's shown in this architecture slide here, but similar concepts about Azure Database for MySQL will apply to wherever you choose to host your app here in Azure. In particular, for this particular architecture, Magento is broken down into smaller microservices to help with the management of it. MySQL is used to store data generated and read by Magento. This includes the inventory catalog, order, and customer information. When you store your data in Azure Database for MySQL, it comes with a built-in 99.99% high availability SLA. This means that the database is always ready whenever a new customer order comes in. In addition, the MySQL service has the ability to scale up to 20,000 IOPS and 16 terabytes of data, ensuring that your MySQL can scale with whatever workload that your store may receive. We also see retailers often running reports at the end of the day. It's often helpful to have a designated reporting server for this case. This ensures that while reports are running, your regular business is not affected. The MySQL service supports up to 5 read-only replicas, and these can be used for generating the reports or helping to scale out read workloads whenever you have a peak busy time. This ensures that while customers are browsing their website, the background report is not affected in any way. Hosting Magento in Azure is made simple with the various app hosting methods that we have to offer. And storing your data in Azure Database with MySQL ensures both the uptime and scalability of it. We have a template available in the Azure Marketplace for you to check out, and it's created by our friends over at Bitnami. Definitely check that out at aka.ms/azure-magento to get started with Magento in Azure. Now, for all the parents that have joined us here today, I'm sure you're doing your very best to keep your kids busy and entertained while schools are closed. During this time, many schools are actually switching over to online learning. One of the most popular applications used for online teaching is Moodle. Moodle is used by educators in K through 12 and colleges to help to manage assignments, quizzes, and communicate with their students. Moodle, much like MySQL, is also open source, and it's developed through community contributions. When you want to host Moodle in Azure, you have various app hosting methods like we discussed earlier from Magento. In this particular architecture slide here, highlighted in blue, the front end of Moodle is actually hosted on Azure Virtual Machine skill sets. The files used for hosting the website are hosted in a virtual machine using GlusterFS. And the data is actually stored in Azure Database for MySQL. MySQL, in particular, is used for storing student scores, grades, and other student information. And when you store data in Azure Database for MySQL, it comes with automated patching and backups. This means that site administrators don't have to worry about taking their own backups and storing them, or even patching MySQL when a new engine version comes out. Because the Azure Database for MySQL service is built in the Community Edition of MySQL, all of the developer tools and frameworks that everyone's already used to using can just be leveraged against the MySQL service itself without having to change anything. In addition, because the MySQL service offers a bunch of different pricing tiers available, the MySQL can be used to scale to any set of concurrent users that are coming in to take assignments or quizzes. Recently, we teamed up with our great friends over at Bitnami to release an Azure Marketplace image that simplifies the deployment of Moodle on virtual machines and uses Azure Database for MySQL to store all of Moodle's data. You can check this out at aka.ms/azure-Moodle to get started today. So now that you've learned about all the cool things that you can do with both of these data services, I'm sure you're wondering how to get your data into Azure. For smaller migrations, you can use the native import-export functionality available built into MySQL and Postgres. But we do understand that some of you are going to have larger scale migrations where you can't afford much of a downtime. And for these types of situations, we recommend the Azure Database Migration Service, or DMS. DMS provides a minimal downtime migration path by essentially migrating your data continuously from a source server hosted on a virtual machine or in another cloud or on-prem into a target server hosted in Azure Database for Postgres or MySQL. And when your migration is done during a small cutover period, you can update your application's connection strings to now point to that server hosted in Azure Database for Postgres or MySQL. We've got step-by-step instructions for how to complete these steps at aka.ms/azure-mysql-migrate and aka.ms/azure-postgres-migrate. So now to wrap things up, I wanted to leave you with a bunch of really great resources to help you get started. First, you can check out our Quick Start documentation to spin up your very first Postgres or MySQL server. And I also recommend checking out our tech community blogs, where we're constantly releasing new blogs about troubleshooting tips or customer workloads that we're seeing. And if you've got additional questions, you can reach us over email, and we'll do our very best to answer those as quickly as possible. I also recommend following both of our services on Twitter to keep up to date with the latest news and announcements for the awesome features that our team's working on at the moment. And I also recommend checking out the GitHub repository for our Citus team to look at some of the really cool projects that the team is working on. And to conclude, on behalf of myself, Samay, and the rest of the team here, I really wanted to thank everybody for taking the time to join us today. I hope everybody's staying happy and healthy. Now let's move on to some questions.
Thank you so much, Andrea and Samay. Okay, the team has been sending me a couple of questions, so I want to pass them your way. The first is, what versions of MySQL does the Azure Database for MySQL service support?
So today we actually offer MySQL 5.6, 5.7, and 8.0, and we're always releasing new versions in our monthly deployment, so you can always keep up to date with those new versions of MySQL that are being released.
Awesome. And now a question for you, Samay. Can the Azure Postgres service be used with time series data?
Yeah, that's a good question. And actually, it's relevant to the scenario we discussed around real-time analytics and applications where you're running real-time analytics on data which is coming in fresh. So a lot of times this data is IoT data, which always generally has a time series component to it. And Postgres has several powerful features around it. So it has several data types to store time series data. It also provides indexing mechanisms such as Brin indexes, which can be used for this purpose. And then, as with pretty much any use case, Postgres has a bunch of extensions relevant to time series data. So we have Timescale DB, which is supported on our service. There's also other extensions such as PG Partman, which will make partition management very easy for you. With features like this, it actually makes Postgres a very good choice for running time series workloads.
Thank you. So following on that, when you think about time series workloads in Citus, this person wanted to know, do I need to use separate Postgres drivers to use Hyperscale Citus?
No, you actually don't. I mean, the main reason for that is Hyperscale Citus is powered by the Citus extension. And this is the power of using extension APIs in Postgres, is that you are actually extending the existing functionality, which means you do not need to use specifically different drivers or different connectors. Like we talked about integrations in addition to the drivers, and actually for integrating with Hyperscale Citus, you could end up using the same set of drivers or the same set of integrations which you would use with our single server database offering as well. So with any Postgres, like whether you're used to PG admin or any other connector, you could use the same connectors for connecting to Hyperscale Citus as well.
Okay, awesome. All right, Andrea, your turn. This person wanted to know why we see a lot of internet scale applications like e-commerce or WordPress especially, or payment applications developed on MySQL.
Yeah, so primarily, like I mentioned earlier, we often see MySQL being used on the LAMP stack, where M is MySQL, of course. And because of the affinity between PHP and MySQL, we often see stuff like WordPress being deployed exclusively with MySQL. And that is just, some developer affinity that's been built up over the years. But MySQL is also great at storing, small scale workloads. So you can scale from very small WordPress applications up to, supporting like big scale payment solutions. So definitely an affinity to the language itself and some of the tools and frameworks that have been built around MySQL.
Awesome. And there was another question about MySQL and high availability, specifically whether you need to provision a second server to get the high availability SLA.
Yeah, great question. So in this particular MySQL service here in Azure, the 99.99% high availability SLA is for every single individual server. So you don't need to spin up like a hot standby or something in another region to get the high availability. You get that all baked in for that very price that we have for MySQL.
Okay. And the next one is, does MySQL support data encryption at rest with customer keys?
Yeah, so we actually are working on a preview right now of a feature that we call data encryption. This allows you to encrypt your data at rest using an encryption key that you bring yourself, and we integrate with the Azure Key Vault for you to store that data and store that encryption key, and it allows you to rotate it so that you can ensure to your auditors for your compliance needs that you are showing evidence of rotation and etc.
Okay. All right, now Samay, here's a popular question. When will Postgres 12 be available on the service?
Yeah, I mean, it is actually a very popular question. I mean, it's also something we've seen raised in user voice and in many other sources. I can assure you we are working on it. Our goal is to release that before the end of the calendar year. On the specific timelines, we'll keep you updated as we learn more on the exact dates on when it will be out. But be assured we are working on it.
Good to know. And I think I knew that already. What about Power BI? Can I use Postgres with Power BI?
Yeah, actually, Power BI has connectors for various sources, and Postgres is actually a supported source. And Power BI provides multiple different ways of querying your data store. We provide, and Postgres supports most of these scenarios. So for example, it supports obviously connecting to Power BI. It also supports auto data refresh at periodic intervals, and it also supports a Power BI feature which is known as direct query. And what you can do with direct query is you can actually, whenever you run queries in Power BI, it queries your Postgres database in real time rather than having to cache the results, which allows you to have your dashboards updating on the fly as people are entering things. So Power BI actually has a very good integration with Postgres.
Okay, and then I know you came from Citus originally, so I know you know this answer. When do you recommend developers consider scaling out with Hyperscale Citus? How big do you need to be to scale beyond one machine?
Yeah, so I mean, that actually is a very it depends question. So I will say it depends. However, the main value proposition you can get with Hyperscale Citus is generally twofold. One is performance and the other is scale. Which is like depending on the nature of the application, sometimes 10 milliseconds performance becomes too slow, And for certain applications, you're looking at a few seconds. Generally, what we've seen is most customers start looking at hyperscale Citus with two motivations. One is if they expect the application to grow to very, very large data volumes, then they want to start with a scalable architecture in the beginning. Or if they are on a single server Postgres database, and then they realize that the rate of growth of the application or the performance they are able to achieve with the current stack is actually hitting limitations either in terms of compute or memory or disk, you can actually scale out with hyperscale Citus. And from describing typical patterns, like it could be anywhere starting from a few hundred gigs to generally single digit terabytes. That's where you end up kind of seeing some kind of performance bottlenecks with a single node database, and their hyperscale Citus can be very useful. To describe the range of customers, we have customers with tens of gigs who had very high amount of performance requirements, so had to use hyperscale Citus for it. And we have customers with over a petabyte of data in a single cluster.
Okay, that's quite the range. Got it. Question for Andrea. Is the Azure MySQL service PCI compliant?
Yeah, so it's PCI compliant, and we also have a number of other certifications such as HIPAA, and we're also FedRAMP High compliant. So that's great news for anybody who does need some type of certification in order to use the MySQL service.
Okay, and here's an administrative question for you, which I know I tripped up on in the beginning. Why do we need the username at service name in the connection string in order to connect to the MySQL service?
Great question. So in our particular service, and this also applies for the single server Postgres service, we've actually got a gateway that sits in front of all of the physical backend nodes that are hosting both of those Postgres and MySQL servers. And so when you actually connect to your MySQL or Postgres server, for instance, you actually use the @server name syntax to tell our gateway what actual backend node to connect to. And that kind of helps with facilitating some of our really cool ML features such as advanced threat protection, because all of that machine learning can be built in directly to our gateway, and that offers an extra layer of protection as well. Oh, Claire, before I forget, I just want to bring up some of our resources just so everybody can take a look at those before we wrap up. I just want to make sure everyone takes note.
To put them back on the screen?
Yep.
Perfect. Yeah, I know that Rachel on our team just posted a blog today on wall to JSON and logical decoding, which I guess is also called change data capture in Postgres environments. So that's on the Azure Postgres blog. And I know your team, Andrea, does quite a bit of blogging on the MySQL one as well. And those are both on Tech Community. So there's some super useful stuff there. We man those email addresses and respond to emails for customers every single day. And would always love more Postgres fans and MySQL fans to follow us on Twitter. We are going to be wrapping up soon. I think we have time for maybe one more question. And it's going to be on MySQL. And it's a question about Azure Cognitive Search Indexers and whether they work with the MySQL service.
Yeah, so we're actually working closely with the Cognitive Services team to get a preview out of some of the new stuff that you can do with them. So definitely check that out. And I'm sure we're going to be blogging about it as soon as all of that stuff is in general availability. So like Claire said, check out the blogs and follow us on Twitter to keep up to date.
Awesome. Thank you both so much for your time. This, I think, has been valuable to everybody who runs their application on top of a database. I'm wondering if we can squeeze in one more question. Is there anything else, Samay, that you want people to know about our Azure Postgres service?
I mean, use it. I mean, I really, I'm a big Postgres fan and have been throughout my career. So I would encourage you to actually follow the links you have on screen. And use the quick start to actually just get started, provision a server, get familiar with the experience, so that and obviously feel free to reach out to us for any questions regarding any of the use cases we discussed, or if you run into any things we can help out with.
Great. Wonderful. Thank you both so much for being here today. And we're going to be doing this twice more. So if you have any friends who missed it, there's 2 more sessions coming up.
Yep. Thanks again, everyone. Really appreciate your time.
Thank you.